So today we'll be seeing questions related to series. There were 8 to 9 questions asked on this topic. So let's see them one by one. So the question 1 says that using Cauchy general principle of convergence, examine the convergence of this sequence Fn, and Fn is defined as this. So we are supposed to use, like in the question itself they have specified that we are supposed to use Cauchy general principle to check if it is convergent or not. So first let's see what is Cauchy's general principle of convergence. So for a given epsilon greater than 0, if there exists a natural number m such that mod of Fn minus Fm is less than epsilon for all n that are greater than this m, then we say that our sequence is Cauchy. Then we say our sequence, which is Fn in this case, is Cauchy. Now let's see, like based on this, if the given sequence Fn satisfies the Cauchy convergence principle. And based on that, we know that in a complete metric space, a Cauchy sequence is convergent. And since we are considering our sequence in real numbers, and which is a complete metric space, so we can just, based on this Cauchy principle, comment that whether the given sequence is convergent or not. So let's verify first if it's let's check if it satisfies the Cauchy principle. So let's calculate Fn minus Fm, and here I am choosing that my n is greater than equals to m. So my Fn minus Fm will be 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by n factorial minus 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by m factorial. And since my n is greater than m, so I can just balance out these many terms from here. So I'll be left with modulus 1 by m plus 1 factorial plus 1 by m plus 2 factorial up till 1 by n factorial, because this term because this Fn term, this term has n minus m plus 1 terms more than this term. So let's see how we proceed further. Now since all these values are positive, so there is no point of adding a modulus sign, because absolute value will be equals to this only, 1 plus m plus 1 factorial plus 1 by m plus 2 factorial up till 1 by n factorial. And we know a result that n factorial is always greater than or equals to 2 raised n minus 1, and it holds for all n belonging to natural numbers. Since n factorial is greater than or equals to 2 raised n minus 1, so from here I can conclude that 1 by n factorial is less than or equals to 1 by 2 raised n minus 1. And it also holds for all n belongs to natural number. Also we are able to do this because we are considering n as a natural number, so none of these terms, neither n factorial neither 2 raised n minus 1, will be 0. These will be positive terms only. So let's see how we can apply this relation above. Now I got my Fn minus Fm as 1 by m plus 1 factorial plus 1 by m plus 2 factorial up till 1 by n factorial. Now if I use this relation for each of these terms separately, so what I'll get is 1 by m plus 1 factorial will be less than 1 upon 2 raised m. Likewise this will be less than 1 upon 2 raised m plus 1, and this 1 by n factorial will be less than 1 upon 2 raised n minus 1. Now I can take this 2 raised m common from all the terms, so I'll get 2 raised m times 1 plus 1 by 2 up till 1 plus 2 raised n minus m plus 1. And if you observe that 1 by 2 is basically less than 1, so I can just use geometric progression, sum of infinite geometric progressions term. So I'll get it as 1 upon 2 raise m times 1 minus 1 upon 2 raise n minus m divided by 1 minus 1 by 2, and it simplifies to 1 upon 2 raise m minus 1 times 1 minus 1 upon 2 raise 1 upon 2 raise n minus m, which will be equals to 1 upon 2 raise m minus 1 minus 1 upon 2 raise n minus 1. And since this term, like the second term, this will be always positive, so I can say that this whole term will be less than 1 upon 2 raise m minus 1, because we are subtracting something positive from this. So we'll be left with this term. Now this whole term, I need to show that this is less than epsilon for some values of m. I need to find out that value of m for which this is less than epsilon. So that I'll get by comparing this. So it will give me 2 raise m minus 1 greater than 1 by epsilon. And from here, if I take log of both the sides, so I'll get m minus 1 log 2 greater than log of 1 by epsilon. And from here I'll get my m as greater than log of 1 by epsilon by log of 2 plus 1. So if I choose my m to be greater than this quantity, let's just name it something. So for a given epsilon greater than 0, we got an m. This is our m. There exists an m, like we can take its greatest integer, because m should be a natural number. So this might not turn out to be a natural number, so we can just take the integer that is greater than this term, like the smallest integer that is greater than this term. So m belongs to natural numbers such that mod of fn minus fm is less than epsilon, and it holds for all n that are greater than the natural number m that we got using this m. So from here we got that our sequence fn is a Cauchy sequence, and we know that in a complete metric space Cauchy sequence is convergent. So from here we got that our sequence fn is basically a convergent sequence. So our sequence fn, which is defined as 1 plus 1 by 1 factorial plus 1 by 2 factorial up till 1 by n factorial, is a convergent sequence. Now let's move on to see the next question. So the next question says that they have basically given us a series and we're supposed to check its convergence. So the series is defined as, let's just name its one term, this term, as something. So let us assume it as an. So my an is equals to 1 times 3 times 5 times 2n minus 1 divided by 2 times 4 times 6 times 2n, and this is multiplied by x raised 2n plus 1 divided by 2n plus 1, and here x is always greater than 0. Now first let's just use a ratio test to see like if that works for this series or not. So let's just find out limit n approaches infinity an by an plus 1. Now if I calculate it, I'll get limit n approaches infinity 1 3 up till 2n minus 1 divided by 2 4 6 2n times x raised 2n plus 1 divided by 2n plus 1 and what will be this term, that is 1 by an plus 1. So this I'll get as 1 divided by 1, 3, 5 up till 2n minus 1 and 2n plus 1 divided by 2, 4, 6, 2n plus 2 times x raised 2n plus 3 divided by 2n plus 3. Now let's simplify it. So after simplifying, I'll get it as limit n approaches infinity 1, 3, 5. Now let me just directly balance out the terms. Those cancel each other. Now if you see that this term, like up till here, it is repeating in this term, so I can just balance out these terms with these terms. Likewise, up till 2n we can just balance out them as well. So we'll be left with x raised 2n plus 1 divided by 2n plus 1 times 2n plus 3 into 2n plus 2 divided by 2n plus 1 into x raised 2n plus 3, and it simplifies to limit n approaches infinity 1 upon x square, and I am just dividing by 4n square throughout, like both on numerator and denominator. So I'll be getting 1 plus 3 by 2n into 1 plus 2 by 2n divided by 1 plus 1 by 2n and 1 plus 1 by 2n. Now if I take its limit as n approaches infinity, so I'll get 1 by x square. Now we know that ratio test converges. Ratio test converges if limit n approaches infinity un by un plus 1 is greater than 0, and it diverges if limit n approaches infinity un by un plus 1 is less than 1. Now, and it fails at, and test fails at x equals, like when this limit turns out to be 1, that is at limit n approaches infinity un by un plus 1 equals to 1. Now since we got our limit as 1 by x square, so for it to be convergent, so it is convergent when 1 by x square is greater than 1. That means my x square is less than 1, and it diverges. I'm writing dgt as divergent. It is divergent when 1 by x square is less than 1. That means it is divergent when x square is greater than 1. Here it is divergent. And when 1 by x square is equals to 1, that means at x equals to 1 and minus 1, the test like fails. So when 1 by x square is equals to 1, that means x square is equals to 1, which basically gives me x as plus minus 1. A ratio test fails. Now we'll use another test to check at these 2 points whether it is convergent or not. So let's do that. So let's use a rapace test to see if it is convergent or not. So that says that rapace test, it says that if limit n approaches infinity n times un by un plus 1 minus 1 is greater than 1, then the series is convergent, and if this limit is less than 1, then series is divergent, and it also fails at x equals. If this limit turns out to be 1, then this test also fails. So now let's calculate what is value of our series. So we need to calculate this, that is limit n approaches infinity n times un divided by un plus 1 minus 1. Now we have calculated this term previously, so let's just plug in the values. So it will be equals to limit n approaches infinity, and here we are considering case when x square is equals to 1. So we'll get it as limit n approaches infinity n times, and we got our un by un plus 1 as this, basically this term, that is 2n plus 3 2n plus 2 divided by 2n plus 1 whole square. 2n plus 3 2n plus 2 divided by 2n plus 1 square minus 1, and this value turns out to be limit n approaches infinity n times 4n square plus 6, that is 10n plus 6 minus 4n square minus 1 minus 4n divided by 4n square plus 1 plus 4n, and it simplifies to limit n approaches infinity n times 6n plus 6 divided by 4n square plus 1 plus 4n. Now if we just calculate its limit, we'll basically get 6 by 4, that is 3 by 2, and this is greater than 1. So we got that at x equals to, at x square equals to 1 also, our series is basically convergent, that is summation an is convergent. So the region in which we got this term as convergent is, so our series, that is summation an, is convergent for all x square that are less than or equals to 1. We got x square less than 1 from this condition, and using Rabi's test we got that it is also convergent when x square is equals to 1. So the whole series is convergent for all x such that x square is less than or equals to 1. Now let's move on to see the next question. So in the next question, again they have asked us to test for the convergence or divergence of the given series. So they have basically given us a series, and we are supposed to check like if where is it divergent and where is it convergent. Also in this case they have given us that our x is taking only positive values, so this is basically a positive term series. So let's move on to see the question. So in this question the series is given to us as this, that is summation un is x plus 2 square x square by 2 factorial plus 3 cube x cube by 3 factorial and so on, and here x is greater than 0. Now if I write it in general term, so the term un will be basically equals to n raised n times x raised n divided by n factorial. Now first let's just use ratio test to see if we can conclude something about the convergence or divergence. So let's calculate this limit, that is limit n approaches infinity un by un plus 1. So this limit will be limit n approaches infinity n raised n times x raised n divided by n factorial multiplied by 1 divided by n plus 1 raised n plus 1 times x raised n plus 1 divided by n plus 1 factorial, and this limit simplifies to limit n approaches infinity n raised n times x raised n divided by n factorial. Let me just divided by n factorial times n plus 1 factorial divided by n plus 1 raised n plus 1 times x raised n plus 1, and this simplifies to, we can write it as like this, n raised n divided by x raised n, we can just balance out x raised n power from both numerator and denominator, times n factorial into n plus 1 times n plus 1 raised n, and in numerator we have n plus 1 factorial as well. Now we know that we can write n plus 1 factorial as n plus 1 times n factorial. So I can just club in these two terms to write them like this, limit n approaches infinity n raised n divided by x times n plus 1 factorial divided by n plus 1 factorial times n plus 1 raised n. Now this n plus 1 factorial we can balance out from both numerator and denominator. So we'll be left with limit n approaches infinity 1 by x times 1 plus 1 by n raise n. So what I have done is I have just taken this term down in numerator and simplified it, and we know what is limit of this. We know that limit n approaches infinity 1 plus 1 by n raise n is equals to e. You can also check it by taking log on both the sides and then simplifying it, so you'll get it as e only. So the whole limit turns out to be 1 by x times e. Now we know that the ratio test converges when the limit turns out to be greater than 1. So it converges when the limit, that is 1 by xe in our case, is greater than 1, that is when x is less than 1 by e, and it diverges when our limit, that is 1 by xe, is less than 1, that is when x is greater than 1 by e. Now also the ratio test fails when this limit is equals to 1. So ratio test fails when the limit, that is 1 by xe, is equals to 1. That means when x is equals to 1 by e. Now we need to separately check for this case, when x is 1 by e, what will be the behavior of the given series. So if you see that the limit, like the term that we have evaluated, basically this term un by un plus 1 involves exponential term. So the best test that comes handy in such cases, basically log test. So what does the log test says? So the log test says that if involves e. So the log test says that logarithmic test, it says that if there exists a series such that the terms, that is un, if un is greater than 0 for any series summation un and limit n approaches infinity n times log of un by un plus 1 is equals to, let's say, L. So the series that is summation un is convergent if L is greater than 1 and series is divergent when L turns out to be less than 1. And also the test fails when L is equals to 1. So in that case we need to use another test. So let's just use this test to see where our series goes for x equals to 1 by e. So in order to apply this test, we need to calculate this, that is limit n approaches infinity n times log un by un plus 1. Now we have already find out what is un by un plus 1, so we'll just plug in the values from above. So it will be limit n approaches infinity n times log of, from here we got it as n by n plus 1 raise n times x. So it is n by n plus 1 raise n times 1 by x, and in our case our 1 by x is basically e. So it will be e here, and it simplifies to, we can write it like this, limit n approaches infinity n times log e times 1 plus 1 by n raise minus n, which is equals to, so next we'll be using this result, that is log of a by b, which is equals to log a minus log b. So if we use that result here, we'll get it as limit n approaches infinity n times log e minus log 1 plus 1 by n raise minus n. So this will be equals to limit n approaches infinity n times log e minus sorry, I've just stated a wrong result. We're not using that result here. So what we are using is log of a times b is equals to log a plus log b, because it is e multiplied by 1 plus 1 by n raised minus n. So it will be log of e plus log of 1 plus 1 by n raised minus n, and that simplifies to log of e minus n log of 1 plus 1 by n. And we got this term because we know that log of a raised b is equals to b log a. So using that result we got this term. So this will be equals to limit n approaches infinity n times log e, which is basically 1, minus n times log of 1 plus 1 by n. Now if you know that this term, that is like this expansion log of 1 plus x, it is equals to x minus x square by 2 plus x cube by 3 minus x raised 4 by 4. So if we use that here, so we'll get it, what I'll get is 1 by n minus 1 by 2 n square plus 1 by 3 n cube and so on. And it simplifies to limit n approaches infinity n 1 minus 1 by 2 n plus 1 by 3 n cube and so on, which is equals to limit n approaches infinity n times 1 minus 1 plus 1 by 2 n minus 1 by 3 n cube plus 1 by 4, it will be n square, plus 1 by 4 n cube and so on. And this 1 balances out this, so it will be equals to limit n approaches infinity 1 by 2 minus 1 by 3 n plus 1 by 4 n square and so on. And if we take limit, it will be equals to 1 by 2. Now this limit 1 by 2 is basically less than 1, and we have seen that the logarithmic test converges when the limit turns out to be more than 1, and it diverges when limit turns out to be less than 1. And since 1 by 2 is less than 1, so series summation un diverges at x equals to 1 by e. So the point where it is convergent is summation un is convergent for all x that are less than 1 by e, and it is divergent for all x that are greater than or equals to 1 by e. Now let's move on to see the next question. So the next question says that they have defined us a sequence, basically an, that is 1 plus 1 by 2 plus 1 by 3 up till 1 by n, and it holds for all n belonging to natural number. Then they ask us that use Cauchy criteria for convergence of sequence and show that this sequence, that is summation an, is not convergent. So if we use, let us assume that epsilon is given to us and it is greater than 0. Then if we calculate a n plus p minus a n, it will be equals to 1 plus 1 by 2 plus 1 by 3 up till 1 by n plus p, minus a n will be 1 plus 1 by 2 up till 1 by n, and this term will be equals to, and since we know that n plus p is greater than 1, here I am considering that my p is greater than or equals to 1. So from here I'll get that my n plus p is greater than or equals to n plus 1. So this term turns out to be equals to 1 by n plus 1 plus 1 by n plus 2 up till 1 by n plus p. And we know that n plus 1 is less than n plus p, less than or equals to n plus p for all p that are greater than or equals to 1. So from here I'll get that my 1 by n plus 1 is greater than or equals to 1 by n plus p. Similarly, what I can show is my 1 by n plus 2 is also greater than n plus p and so on. So my term, that is modulus of a n plus p minus a n, which is equals to 1 by n plus 1 plus 1 by n plus 2 up till 1 by n plus p. Since all these terms are greater than or equals to 1 by n plus p, so I'll get it as 1 by n plus p plus 1 by n plus p up till 1 by n plus p. And these are basically p terms, because if you see that it is first term, that is n plus 1, second term is n plus 2, and we are going till n plus p, so there are p terms, so it will be equals to p divided by n plus p. Now if I take a particular case, because in order to prove it divergent I just need one case to discard, that it's not convergent. So if I prove that there exists at least one p for which this turns out to be this turns out to be greater than our chosen epsilon, then I can conclude that it's not convergent. So in particular, let me choose that my p is equals to, let's say, n. You can take any other value as well, like anything that you wish, that discards it. So if I take this case where p is equals to n, so my an plus p minus an will be equals to mod of a to n minus an, which will be equals to n divided by n plus n, which will be greater than or equals to, because we got this sign earlier, so it will be greater than or equals to n divided by n plus 1, n plus n, which is equals to 1 by 2. Now if I choose my epsilon, let me choose my epsilon equals to 1 by 3, which is also greater than 0. So now if you see that my an plus p minus an, which turns out to be greater than 1 by 2, this is not less than my epsilon, that is 1 by 3, because my 1 by 3 is less than 1 by 2, so this will turns out to be greater than epsilon. So basically I got a number p for which it is not satisfying Cauchy criteria, that is for epsilon equals to 1 by 3, my sequence an is not satisfying Cauchy criteria for convergence. So from here I can conclude that my sequence, that is an, is not convergent. That means my sequence an is divergent. Now let's move on to discuss the next question. So next question says that apply Cauchy's principle of convergence to prove that the sequence fn defined by this is not convergent. So if you observe that this question is similar to the previous question that we just discussed, so let's just use Cauchy principle to show that the sequence is not convergent. So let's see, the given sequence fn is basically 1 plus 1 by 4 plus 1 by 7 up till 1 plus 3n minus 2. Now let us assume that epsilon greater than 0 be given. Then if we calculate modulus of fn plus p minus fn, so what we'll get is modulus of 1 plus 1 by 4 plus 1 by 7 up till 1 by 3n plus p minus 2 minus 1 plus 1 by 4 1 by 7 plus 1 by 3n minus 2. Now if we just simplify these terms, so what we'll be left with 1 divided by 3 raised n plus 1 minus 2 plus 1 by 3 raised n plus 2 minus 2 up till 1 by 3 raised n plus p minus 2, and it simplifies to modulus of 1 by 3n plus 1 plus 1 by 3n plus 4 up till 1 by 3n plus 3p minus 2, which is equals to, now since all these terms are positive, so I can just take them out of the modulus sign. So it will be equals to 3n plus 1 plus 1 by 3n plus 4 up till 1 by 3n plus 3p minus 2. Now if I take my p, let me take my p as n plus 1, So this term, that is fn plus p minus fn, will reduce to modulus of f2n plus 1 minus fn. That will be equals to 1 by 3n plus 1 plus 1 by 3n plus 4 up till 1 by 3n plus 3n plus 1. That is equals to 1 by 3n plus 1 plus 1 by 3n plus 4 plus 1 by 6n plus 1. And all these terms we know that 3n plus 1 is less than equals to 6n plus 1 for all n belongs to natural number. So from here what we'll get is 1 by 3n plus 1 will be greater than or equals to 1 by 6n plus 1. Likewise, we'll get 1 by 3n plus 2 less than or equals to 6n plus 1. And from here we'll get that 1 by 3n plus 2 is also greater than 1 by 6n plus 1. And likewise we can do for other terms as well. So from here what we'll get is f of 2n plus 1 minus f of n is equals to 1 by 3n plus 1 plus 1 by 3n plus 4 up till 1 by 3n plus 1, and it will be greater than or equals to 1 by 6n plus 1 plus 1 by 6n plus 1 up till 1 by 6n plus 1. Now if you see that these are n terms, like, because if you these are n terms, so it will be equals to n divided by 6n plus 1. Now if we see that this will be greater than, we know that our 6n, that like we know that our 6n plus 1 will be less than or equals to 6n plus n for all n belongs to natural number. So from here what we'll get is 1 by 6n plus 1 will be greater than or equals to 1 by 7n. And if we use this relation, or let's just multiply with n on both the sides, so what we'll get is n by 6n plus 1 will be greater than or equals to n by 7n. So this term turns out to be greater than n by 7n, which is equals to 1 by 7. Now if I take my epsilon to be, let's say, 1 by 8, so let epsilon equals to 1 by 8. So this term turns out to be greater than epsilon. So from here we got that our given sequence is not satisfying Cauchy criteria for these terms. So from here we can conclude that this sequence is basically a divergent sequence. Since the sequence fn is not satisfying Cauchy criteria, so the sequence fn is not convergent. And we are able to comment this because we are in complete metric space, and in a complete metric space a Cauchy sequence is always convergent. So if it is not convergent, then it's enough to show that it's not Cauchy. So from here we conclude that our sequence fn is a divergent sequence. Now let's move on to see the next question. So the next question says that find the range of P for which this series is absolutely convergent and conditionally convergent. Now if you observe that this is basically a question of alternating series, so I'll discuss this question in that series only. That will be next video from this one. So we'll just leaving this question for now and we'll discuss it in a next video. So let's move on to see the next question. So the next question says that show that the given series is basically convergent. So the series that is given to us is this: summation un is equals to summation n equals to 1 to infinity pi divided by pi plus 1 raise n times n raise 6. So we are supposed to show that it is convergent. So first test that comes to our mind is basically ratio test. So let's just use that only. So for that we need to find out this limit first, that is limit n approaches infinity un by un plus 1. So if we see that, it will be equals to limit n approaches infinity pi divided by pi plus 1 raise n times n raise 6 multiplied by 1 by pi divided by pi plus 1 raise n plus 1 times n plus 1 raise 6, and it simplifies to limit n approaches infinity pi plus 1 divided by pi times n divided by n plus 1 raise 6, and it is equals to limit n approaches infinity pi plus 1 divided by pi times 1 divided by 1 plus 1 by n raise 6. Now if we just take its limit, it will be equals to pi plus 1 by pi, which is equals to 1 plus 1 by pi. So in any case this limit is basically greater than 1. So, and we know that a series summation an is convergent if limit n approaches infinity an by an plus 1 is greater than 1, and divergent if this limit, that is limit n approaches infinity an by an plus 1 is less than 1, and the test fails, and test fails at limit n approaches infinity an by an plus 1 equals to 1. So if you see that in our case our limit turns out to be greater than 1. So from here we can say that our series is convergent, since our limit, that is limit n approaches infinity un by un plus 1 is equals to 1 plus 1 by pi, which is greater than 1 for all n. So from here we can conclude that by ratio test our series is convergent. Now let's move on to discuss the next question. So the next question says that they have given us a series, and in the question itself they have said that, like, they have provided that it is convergent. We are just supposed to prove that it is convergent. So in order to prove it is convergent, let's see what is the first, like, what is the general term of series. So I can write my given series as it is 1 by 3 square plus 1 times 4 times 3 times 6 square plus 147 3n minus 2 divided by 369 up till 3n square, and so on. So from here, if my series is summation un, then from here my un term will be equals to 1 times 4 times 7 up till 3n minus 2 divided by 3 times 6 times 9 up till 3n whole square. Now first let's just use ratio test and see if we are able to conclude something from there. So for ratio test we are supposed to find out this term first, that is un by un plus 1. So if we calculate it, it will be equals to 1 times 4 times 7 up till 3n minus 2 divided by 3 times 6 times 9 up till 3n whole square, and the term 1 by un plus 1 will be equals to 3 times 6 times 9 times 3n plus 3 divided by 1 times 4 7 3n minus 2 and 3n plus 1 whole square. So it will be equals to, like, we can just balance out the common terms, since like all these terms still here, like these terms can be balanced out via this. Likewise, these terms can be balanced out from these terms. So what we'll be left with is 3n plus 3 divided by 3n plus 1 whole square. Now let's see what will be its limit. So limit n approaches infinity, un by un plus 1 will be equals to limit n approaches infinity, 3n plus 3 divided by 3n plus 1 whole square. So it will be equals to limit n approaches infinity, 1 plus 3 by 3n divided by 1 plus 1 by 3n whole square. And if we just calculate its limit, so it will be equals to 1. Now if you see that the ratio test fails when the limit turns out to be 1, so by ratio test we can't comment anything. So now let's use just Rabi's test. So using Rabi's test, so that says that a series, if this limit, that is limit n approaches infinity, n times un by un plus 1 minus 1, if it is, let's say, equals to L, so the series is convergent if this limit basically turns out to be greater than 1, if L is greater than 1, and divergent if L is less than 1. So let's see like what we get after calculating this limit. So now let's just calculate this limit. So it will be limit n approaches infinity n times, we have already find out this term, that is un by un plus 1, so it is 3n plus 3 by 3n plus 1 whole square, 3n plus 3 by 3n plus 1 whole square minus 1. So if we just simplify it, it will be equals to limit n approaches infinity n times 9n square plus 9 plus 9 to the 18n minus 9n square minus 1 minus 6n divided by 3n plus 1 whole square, and this simplifies to limit n approaches infinity n times 12n plus 8 divided by 3n plus 1 whole square. Now if we just calculate its limit, we can just divide by n square in both numerator and denominator. So what we'll get is limit n approaches infinity 2 plus 8 by n divided, it is 12 plus 8 by n divided by 3 plus 1 by n whole square, and if we just take its limit, it will be 12 by 9, which is 4 by 3, and it is greater than 1. So since this limit is greater than 1, so we can just say that the series converges. The series converges by Rabi's test, because that's the criteria for convergent of the series using this test, that is limit should turn out to be greater than 1, which is 4 by 3 in this case. So now let's move on to discuss the next question. So the next question says that discuss the convergence of the given series. So the series that is given to us is this. Now let's just write its general term first in order to apply any test. So the series is, let's name it as summation un. So it is equals to x by 2 plus 1 by 3 divided by 2 by 4 x square plus 1 by 3 times 5 divided by 2 times 4 times 6 x cube, and so on. And in this term, x is given to us as greater than 0. Now if we just write its general term un, so it will be equals to 1 times 3 times 5 up till 2n minus 1 divided by 2, 4, 6 2n times x raised n. And if we use ratio test, so by ratio test, let's just calculate this term first, that is un by un plus 1. So it will be equals to 135 2n minus 1 divided by 246 up till 2n times x raised n multiplied by 135 2n minus 1 times 2n plus 1 divided by 246 2n times 2n plus 2 and x raised n plus 1. So this limit simplifies to, after balancing the common terms, we'll be left with 1 by x times 2n plus 2 divided by 2n plus 1. Now if we just take its limit, that is limit n approaches infinity, un by un plus 1, it will be equals to 1 by limit n approaches infinity 1 by x times 1 plus 2 by 2n divided by 1 plus 1 by 2n, and if we just take its limit, it will be equals to 1 by x. And we know that like ratio by ratio test, the given series un is convergent if the limit, that is limit n approaches infinity un by un plus 1 turns out to be greater than 1, and it is divergent if this same limit is less than 1, and test fails if this limit is equals to 1. So the given series summation un is convergent when r1 by x, that is our limit, is greater than 1. That means x is less than 1, and series summation un is divergent when 1 by x is less than 1. That means x is greater than 1, and test fails when 1 by x is equals to 1. That means when x is equals to 1. Now let's check again using another test at this value, that is when x is equals to 1. So using Rabi's test, in case when x is equals to 1, so in this case my un by un plus 1 will be equals to 2n plus 2 by 2n plus 1, 2n plus 2 by 2n plus 1. Now if we just calculate its limit, that is limit n approaches infinity n times un by un plus 1 minus 1, so it will be equals to limit n approaches infinity n times 2n plus 2 by 2n plus 1 minus 1, so it will be equals to limit n approaches infinity n times 2n plus 2 minus 2n minus 1 divided by 2n plus 1, so it will be equals to limit n approaches infinity n times 1 by 2n plus 1. Now if we just find out its limit, it will be equals to 1 by 2, which is less than 1. So by Rabi's test, since this limit turns out to be less than 1, so at x equals to 1, summation un is divergent. So if we just club in the results of ratio test and Rabi's test, we'll get that our series, that is summation un, is convergent for all x that are less than 1, and summation un is divergent for all x that are greater than or equals to 1. Now this completes our question on series, and in the next video we'll see questions on alternating series. There are only 2 to 3, I guess 3 or 4 questions on that topic, so we'll see them in next video. So thank you for watching, and please do like, share and subscribe the channel.